So when we have two lines on the number plane, if they're straight lines, then unless they're parallel, they will eventually cross at a point. So to find that point of intersection, what you have to do is find the x value and the y value that satisfy both equations at the same time. So you need to solve them simultaneously. So thinking back to when we started that in our algebra topic, you'll either need to substitute one equation into the other or eliminate one of the variables. So what you're going to do depends on what the equations are, and if that's something that you're a bit rusty on, then go back and have another look at that video. That's why they're there. You can go back and review anytime you need to. Okay, so we have these two equations. We have 3x plus 2y minus 1 is equal to 0, and x minus 2y plus 5 is equal to 0. Now I'm going to call this equation 1 and this equation 2, and then I'm going to make my notation so that I know what I'm doing as I solve them. Now if you have a look, equation 1 has a positive 2y and equation 2 has a negative 2y. So if I add those two equations together, I will eliminate the y's and just have an equation in x, which I can then solve. So when I add them together, 3x plus x gives me 4x, 2y minus 2y disappears, minus 1 plus 5 is plus 4, and 0 plus 0 is 0. This is a very easy equation to solve, so 4x equals negative 4, so x is equal to negative 1. So once you have your value for x, you're going to substitute back into one of the equations. Now, it doesn't matter which one you choose. I'm choosing the second one because then it's just x and I don't have to worry about multiplying it or anything like that. So when I substitute it in, I get minus 1 minus 2y plus 5 is equal to 0. So then minus 1 plus 5, I get 4 minus 2y is equal to 0. So then 4 is equal to 2y and y is equal to 2. So the point of intersection is the point negative 1, 2. Now in our second example, we've got this word concurrent. So concurrent means that they all meet at the same point. So what we're trying to show is that these three lines all cross at the same point. Now trying to work with three equations at once is a little bit difficult. So what you do is you solve two of them simultaneously, just like we did in the first one, and then you show that that point also works for the third line. So again, you get to pick which equations you're going to work with and how you're going to do it. I am going to call this one my equation 1, this one equation 2, and this one equation 3. So I'm going to work with equation 1 and equation 2. Again, it doesn't matter which ones you do. So I have 2x minus y plus 1 is equal to 0. That's equation 1. And I have 3x minus y is equal to 0. And that's equation 2. So what I'm going to do is just do a quick review here of the substitution method. So from equation 2, 3x minus y is equal to 0, then I know that 3x is equal to y. So once I know what y is, I'm going to sub into equation 1. So then I get 2x minus y, so 3x, plus 1 is equal to 0. So that tells me that negative x plus 1 is equal to 0, which means that x is equal to 1. So then you need to substitute that into one of those two equations. I'm choosing the second one just because it's simpler. So if x is equal to 1, then we get 3 times 1 minus y is equal to 0, which means that y is equal to 3. So what I know is that equation 1 and equation 2 meet at the point 1, 3. So what I need to do is substitute that into the third equation and show that it satisfies that equation 2. So this is the equation that I need to check. So I'm going to start obviously with the left-hand side because there's nothing to substitute into the right-hand side. So 5x, so we get 5 times 1 plus 2y, so 2 3s minus 11. So you work all that out, and that is equal to 0, which is equal to the right-hand side. So therefore, the point 1, 3 does lie on the line, and so therefore the lines are concurrent.